we'll share screen. And cool, I think we're good to go. All right, so any kind of wrap-ups, takeaways, thoughts, comments on homework 7, on dialogue, on sort of the whole thing?
I have a question about homework 8, if you have time for that.
Yeah, let's talk about that too.
So I've got my program basically done, but I have one particular edge case where I'm running into an issue. There's a section in the very last paragraph of Wuthering Heights where it talks about donations.
Okay.
It has a dollar symbol, and then it's followed by the number 1, and then the dollar symbol followed by the number 5.
Right.
So I have a problem echoing those statements back to the screen as keys from the associative array.
Okay.
Just interpreting them as the inputs to the command instead of as the $1. And
right.
I'm not sure how to
and someone else was having similar issues. It should work automatically. You need to be a little careful with using quotes. So let's say we're reading a line and it says, donate $1 and $5. So if I echo $line, that's still in there. If you do right, so I can store something associated with that, and then let's iterate over the entries in our hash. Let me. Let me tag this. So if we iterate over the elements in our hash, so let's do a for loop. So for key in, and then this funny syntax, string curly bracket exclamation mark. The exclamation mark, by the way, someone asked yesterday, although he's not, oh yeah, he isn't here. The exclamation mark tells us that we want to iterate over the keys. If we leave that off, then it says we want to iterate over the values. So that's what the exclamation mark does. So let's go hash bracket at. This is a key, not a hey. Right. So so the key is equal to 4 things there. I ran into this yesterday. Spent about 10 minutes figuring out why this was coming out on separate lines yesterday, and I finally figured it out, and it was something silly, and now I'm having trouble figuring this out again. So that's $line. There we go. All right. So there's the key, and it should not gobble up those $signs directly. But if, for example, I do this from the command line, if I say something like hash bracket quote. Right. So here, my bash shell is going to take these things inside double quotes, and it's going to replace this with the value of $6, which is empty, and $12, which is empty. So the key it's going to use here is space and space. And when I iterate over my keys, right, I can see that new key. But if I'm in a bash script and I have a variable that contains these $signs, right, I should be able to use that to reference an index in the hash, and it should not gobble those up. So my first question would be, right, is this happening in the script, or is it happening when you do this interactively? And if it's happening in the script, try to pare it down to a minimal example that illustrates this problem, right? In other words, 3 or 4 lines of bash code that set a variable equal to something with $signs and then tries to use that to store something in the hash and then pull something out. And that illustrates that the $sign is getting gobbled. You can start getting into escapes, right? Throwing backslashes in front of things. And, if you're doing this interactively, you might be able to do that. Right? But you should not have to do that if this is sitting in a bash variable. Yeah, if you can pare it down to a example that just illustrates whatever that problem is, we can look at that.
Okay, I'll send you an email later. Thank
Okay,
you.
yep. All right, other questions? Everyone good on homework 8? All right, awesome. Oh yeah, let's see, there was a TR question. How do we get rid of single quotes? TR, so TR works nicely for, right, so you can't truncate, but you could change all the characters you want to get rid of. I suggested into, like an @ sign. Right, and then you can take that and you can pipe it into sed. Right, and that should just squeeze them out. And if you want to get rid of double quotes, if you're putting your string inside single quotes, right, that'll gobble that up nicely. And if you want to do both of those, right, we could tr a double quote with an @ sign, and then put that into TR and do a single quote to an @ sign, and then get rid of all of your @ signs. Right, and there's switches you can put on these things, and there's escapes you can do, and so on and so forth. I have a simplistic way of approaching programming. I try to take what I know and make it work. At some point, you need to expand what you know and add more things to your repertoire, or maybe you just get bored and you do that. But hold on a second. I never have my ringer on, but Amazon is having difficulty opening the door of the building, so got my ringer on. So it's, for me, it's more fun to like know a few commands and then just find ways to put those together to do what I want to do. So, but there's other ways you can backslash quotes and put these together into one command and so on. Whatever works for you is good. All right, other questions? I don't actually know what the tr-d switch does, but Jennifer mentioned that. NTR. Oh, delete. Cool. Well, that's handy. When trying to use set in my program, I got an error message saying that it needed a file. It needs something feeding it, but you can feed standard into it. So I can take date and pipe that into sed. And use that to remove all the spaces from date, for example. If I just do sed, it generally won't complain. It'll just sit there and try to read from standard in. If it's actually complaining that it needs a file, I'm guessing maybe there was a switch on it that's supposed to be a file name or something. But I don't know. Maybe if you can give me more specifics. But yeah, normally it either reads from standard in or well, normally it just reads from standard in.
So, can you hear me?
Yeah, yeah.
Okay, so I actually had a TR and I deleted my symbols, the oddball ones, and then I did the pipeline and then, or the pipe, and then I had sed, and then what information I wanted to get rid of the @ signs, because at that point I had changed them all to ats, and it kept saying that I needed a file name that went along with it.
And was it just like this?
Yeah, but just before it, I had TR, and I had changed my symbols to the @ sign, and then I had the pipeline, or pipe, and then I had that information. Yep.
Like that? That should work fine.
Okay. Well, I'll play around with it some more.
Yeah, send me a copy from your terminal session if you don't figure it out.
Okay.
Cool. So let me mention something in here that can be helpful. Let me just write some junk code here. So I think this was a midterm question or something. I'm just printing out a table of squares, right? So I'm initializing I to 0, and I'm just going to calculate I squared. I'm going to output those, and then I'm going to increment I and go through a loop like this, and we'll fizz buzz it here. Right. So if you're writing a script and you're trying to figure out what's going wrong with it, here's a little hint. In your shebang at the top, put a -x switch. Okay, this bumps up the verbosity level of bash, and it will show you what it's doing as it executes your script. So if I run this, right, I get lots of output along the way, showing me, I is being set to 0. It's doing a comparison statement here, setting I2 to 0. It's about to do an echo. There's the result of the echo. It's checking to see if if something's equal to 3, 0 is equal to 3. Now it's setting I equal to 1. It's checking to see if 1 is less than 5. This gives you a lot of output, right? But it can help you see what's going on inside without having to type, a whole bunch of echo statements into your script itself. So just putting this -x at the end of your bash can help you with that. And it's a general switch, right? I can start a bash session with a -x, and it shows me everything that's happening inside my bash rc file. And you know, every time you do something, it shows the result of it, and so on. So yeah, that can be a useful trick. All right. Reading from standard in. So you've probably already got this nailed down for homework 8, but just to reiterate, we can do this while read statement. So let's say hello. Here's our main input loop. So while read var, this is like a read var statement, but it's going to do it repeatedly. So I'm going to say I'm inside the loop, and I'm going to say variable equals string var, and I'm going to say done, and I'm going to put a message when I'm outside the loop. So if I run this, right, it says hello. And there's testing. I'm inside the loop. 1, 2, 3, haha, and so on. Right. So when I want to get out of this, what do? I hit Control D in the beginning of a line. If I type some stuff and I hit Control D, it doesn't trigger the magic end of file. But at the start of a line, if I just hold down Control and hit D, then my read statement will treat that as saying it's hit the end of the input, and that while loop will exit, and then in this case I came outside my loop. Right. So this is probably the main structure you're going to use around the first half of homework 8, right, which is reading, cleaning, and tallying the phrases. This reads one line at a time, and then lets you take that line, convert to uppercase, get rid of characters, change spaces, break it into phrases, pull out each phrase, tally it in your hash. And then when you're all done with your input after this, right, you would go ahead and you'd do whatever you have to do to go ahead and output the result of your tally. So just iterate over the things in your associative array, print out the tallies with each phrase. Let's see. How do I go about feeding sed a file inside a script? So if you're in a script, or if you're not in a script, right? Sed normally reads from standard in. I can apply this to a file by just listing the file as a third argument after my substitution command, right? And that will apply this substitution to the contents of this file. It writes the result to standard out. It doesn't modify this file, but if I wanted to do something with this, right, I could take this and put it into, you know, temp bash rc. And now temp bash rc is my modified version, and then I could copy that on top of my original file if I wanted to replace that in place. Okay, cool. The other option is you know, I could redirect standard in from this file, and that would do the same thing. The other option is I could type the contents of this file using cat and redirect the output of that into the standard input of sed, and that'll work as well. And so this was another thing I wanted to touch on, this idea of input and output streams. In Linux, right, whether we're in Bash or in a C program or something else, there's three things that are called streams. They're called stdin, stdout, and stderr. And even though we talk about reading from the keyboard or displaying something on the display, we're really, reading from a stream called stdin and writing to a stream called stdout or stderr. And by default, stdin is your keyboard, stdout is your display, stderr is your display. But when you run a command and you say greater than, some file, what's happening is stdout is being changed. Stdout is being redirected to this file, and anything that this command produces that would normally appear on your screen goes into this file instead. When you run a command and you say less than, like your homework 8, less than some test file, what's happening is stdin is being modified for this command so that it reads from this file. If you say C1 and you pipe that into C2, what's happening? Stdout of C1 is being changed to not go to your display, but to go into what's called a pipe, right? So it's basically entering one end of this pipeline. And C2 is being executed, but its stdin has been redirected to come from the other end of this pipeline. So you have a setup like this, and this is how the output of C1 goes into the input of C2. So these streams are fundamental to most of what we do in Linux. And when you do an fget, for example, with a string and a length and stdin, right, this third argument, you're identifying what stream you want to read from. And if I read from a different stream, then instead of reading from the keyboard, I would be reading from, whatever that stream corresponds to. And we'll touch again on these ideas of like fopen and fclose and so on. These are ways that we can create new streams that correspond to files. But we can also use this to interact with, other devices, with network connections, with all kinds of things. All right, so I just wanted to mention the idea of those again. We'll dig deeper into them later. All right, so tomorrow I want to, what do I want to do? I want to start talking about processes in Bash, working with processes, understanding process structures, and then segue that into looking at processes in C. All right, have a good afternoon. I will see you next time. Thank you.